Okay, so good morning to all of you. Good morning. Acha, Nitya. Good morning, good afternoon, whatever you can say. Online students, am I audible? Roja, am I audible? I can see you. Audible? Okay. Oh, sorry. Hello, check. Hello, check. Yeah, now. So, am I audible, online students? No? अच्छा, यहाँ से नहीं आ रहा है? Hello, I'm audible? Okay. Is the sound quality okay at your end? Okay, okay. Okay, so let us begin with science and technology portion. So I see some old faces at from Rouse. I recognize Nitya. I recognize some of you. Okay, so good that you are here. So with respect to science and technology, uh, I hope some of you have given exam before, and you would have realized the importance of this particular portion also in your prelims paper. In mains, yes, the weightage is less. But what about the weightage in your prelims paper? How many questions will you expect from science and technology? 15 plus? So science and technology, you, or if you compare it with other subjects, the weightage is quite significant. So we focus on bigger subjects, but for competitive exams you cannot ignore smaller subjects like science and technology portion. And science and technology, you would see that it is not only about current affairs, so you would need to have some good understanding of basics, and then on top of that, if you're good at current affairs, then you'll be able to tackle the questions better. This you would have realized by seeing the pyqs also before, that the questions on bacteria and viruses that are coming, do you think you can solve that by only current affairs knowledge? Probably no. So you would need some basic grounding also. If you look at space science and technology questions, they would be asking very basic questions on space also, or some advancements in space. So they would be asking not only about technology, but they would be asking also questions on the basic concept of space also, like birth of a star, death of a star. ये इस पे सवाल बने हैं लास्ट ईयर भी. हाँ, so what are Cepheids, what will happen to our sun, what will happen to a high mass star, those type of questions. And you might have come across even Einstein's theories questions also. So gravitational waves, ये सवाल बने हैं. Yeah, Higgs boson, gravitational waves. So those questions have been asked, and they might not be in present news. They might be in the news for past 2 3 years, but they are now part of your basics only. So what we will be doing in these classes, that will be discussing the basics also. I guess I shared on the group some current affairs part also. So this part that I have shared is mostly the current affairs part. So what has happened in past 1.5 year, we have covered that. So what is relevant for exam, we have covered that portion, but it doesn't cover the basics part. So basics will be discussing in the class, and I'll be referring or asking you to refer to some new developments. If I'm teaching that particular topic, let's say gravitational waves, I can ask you to refer to that particular page, and you can make some notes there itself. What topics are important in science and technology, like if you have covered classes before, have all of you done science and technology before? Like, have you done some foundation course before? सबके पास अपने कुछ बेसिक नोट्स हैं, या किसी के पास नहीं भी हैं? So you are not having any notes before of science and technology, so this is the only time that you are attending science and technology. Does that also reflect the way we treat science and technology? Science and technology ऐसा लगता है कि ये तो बस न्यूज़पेपर पढ़ करके हो जाएगा, and that is why we ignore it also. And do you think ignoring such a subject would be beneficial for you in the exam? Now I think now it is better. Yeah. So in a competitive exam, you have to analyze this part, that if you're filling a bubble, it means you're attempting a question, and if you're getting that bubble wrong, how much marks are you potentially losing? Yes, so you know this fact, that if you're filling a bubble and you're getting it wrong, you're losing 2.66 marks. CSAT आप लोगों ने दिया होगा, बहुत लोग 66.6 पे भी होंगे. And even by one, if you had not done one question wrong, you would have got into So even for GS paper also, you cannot ignore subjects like this. So if there are 14-15 questions of science and technology, at least you should feel comfortable in attempting 10 to 12 questions, and out of that, if you are able to mark 70-80% questions right, then your job is done. Yes, we cannot mark all questions right in science and technology because there are always bouncer type of questions given by UPSC, but at least basics you should be knowing. And if there is a current affair which was very very obvious, that you should not be missing. That is the idea of the class also, that basics you should not be able to miss out, and current affairs which was very very relevant, you should not be missing out. So we'll be beginning with different topics. First topic that we'll be beginning with will be space science and technology. So broadly, what would be the scheme of the class? So we would cover space science and technology portion first, then we would cover nuclear science and energy. This particular topic has become very very relevant for your exam. Have you seen questions on energy technology being asked from past 2-3 years? Questions on fuel cells, questions on green hydrogen, questions on biofuels. So this topic is not exclusively mentioned in your syllabus, but they are asking questions. So this topic has become an important topic from exam perspective. So you should be prepared for this particular topic also. After this, we can look at let's say IPR or nanotechnology. This is a small topic. IPR is a small topic that we can cover. A defense we can cover. And biotech we can cover last, or if you are comfortable, we can cover before also. So this is an important portion, biotechnology. So these are some important themes for our exam that you should be comfortable with. So beginning with space. So space, what are important topics in space that we will first list it down, then we can cover. So in space science and technology, अच्छा स्पेस के करंट अफेयर्स आपके दिमाग में क्या क्या है which would be relevant from exam perspective? Satellites, okay. स्पेस एक्सपेरिमेंट्स, कौन से स्पेस एक्सपेरिमेंट्स? स्पीड एक्स हुआ, आदित्य हुआ, या और चंद्रयान, चंद्रयान 3, चंद्रयान 4, गगनयान. So you're focusing on missions part. Observatories, okay. So sun satellites like nisar, yeah, that is in news. Yeah, okay, true. Space stations would be in news, yeah, true. So what we can do, we can cover through basics, and we'll also inject into it or insert some of the current affairs topic also. So we will first begin with the basic part here. So in basic, we'll try to understand the very origin of universe itself and the most popular theory. So Big Bang theory, there are some concepts that you should be knowing from this particular topic perspective also, because lots of development keeps on happening with respect to this particular theory also. Composition of universe. Composition of universe. So have you heard terms like dark matter, dark energy? इसके लिए कोई मिशंस हैं? कोई मिशंस हैं जो आपको पता होने चाहिए? कौन से मिशन? So we'll discuss about composition of universe. What do we mean by real matter? What do we mean by dark matter? What do we mean by dark energy? Not many missions are there, but at least one you should be aware. Then we can get into our solar system. This particular topic falls, or it would overlap with geography, but we will look at it from different perspective, that what would be relevant for space concepts. So there are many concepts in solar system which you should be knowing. The structure of solar system is quite important. Structure of solar system. So what are different parts of the solar system? What is the outermost part? What is the innermost part? So those part you should be knowing. What do you mean by Kuiper belt? What do you mean by Oort cloud? Where are asteroid mostly located? So those structure part you should be knowing. Then the source of light or source of energy for the whole solar system is sun. So sun is a star. So for a star, you should know how a star is born. So you should be aware about birth of a star, how a star is born, its activities when it is in main sequence, you should be knowing. So questions have been asked on solar flares, solar storms. So you should solar cycles also. So if you know what are the activities of the sun, then you can answer such questions also. Then you should also know the death of a star. So this would cover sun in some holistic manner. Then we should also know about why do we call something as planets. For example, Pluto for very long from 1970s till 2006 was considered to be a planet, but in 2006 it was chucked out of the list of planets. Why? So you should know the criteria. You should know some other basic concepts linked to planets, like Kepler law. You should be knowing, aware about Kepler's law. Okay, क्योंकि इस लॉ के बेसिस पे आप दूसरे कॉन्सेप्ट भी समझ सकते हो, जैसे लैंगरेंज पॉइंट्स जो हैं वो आप इस लॉ के बेसिस पे भी आप समझ सकते हो. सो दैट इज व्हाई वी विल बी डिस्कसिंग. नाउ देयर इज अ लॉट ऑफ फोकस ऑन स्मॉल बॉडी सिस्टम नाउडेज. Small body system of solar system, it includes what? Yeah, asteroids, meteors, and yeah, we'll see that distinction between meteors also, and comets. Why there is a lot of focus on this particular object, asteroids? You would have heard that we have collected sample from an asteroid. Okay, so it could be used for different purposes. So asteroids we are studying for different reasons, and we also fear asteroids. Why? Because it can hit the earth. Dinosaurs got killed, so we are aware about that kind of situation. So we want to protect earth from that. So what are earth protection system, we'll try to know. So but you should also know the basics of what do you mean by asteroid, what do you mean by meteors, what do you mean by comets, and then linked to this we will also see some missions. So we have missions to sun, we have missions to planets, we have missions to asteroids also. So we will try to see the different missions also after we are done with the basic part. uh, Another basic part would be your earth orbits. So UPSC has been asking questions from this area, earth orbits. So have you come across these terms like low earth orbit, then geosynchronous orbit, geostationary, yeah, geostationary orbit? So what do you mean by these orbits? Polar orbits, sun synchronous orbit. What is the significances of these orbits? You should be knowing. Transfer orbit, have you come across this transfer orbit? So there is a concept embedded here in transfer orbit, which is gravitational slingshot. Came across this? Okay, so we'll be discussing this, and we will see where do we use these kinds of mechanisms also. And linked to this would be another important concept, which is Lagrange points. ये पढ़ लिया होगा एग्जाम के लिए. Okay, what are halo orbits with respect to Lagrange points? ये पढ़ लिया. Have we landed on south side of moon? Have we landed on the dark side of moon? Are the dark side and the south side same? No. Which country has landed on the dark side of the moon? China has landed on the dark side of the moon. So can it, or can we land on the dark side of the moon without sending a relay satellite to L2 point? Are you aware about this situation? That in order to land on the dark side, it is more difficult than landing to the south side. So India became the first country to land on the south side, but China is the first country to land on dark side of the moon. So what is dark side? You should know the concept. How to land on the dark side? You should know the concept. To know that, you have to know halo orbit of Lagrange points. आदित्य का भी जो नाम आप देखते हो, आदित्य L1 है, वो L1 पे नहीं है, halo orbit of L1 पे है. So are you aware about this situation? So what is halo orbit of L1, halo orbit of L2? So why we place at halo orbits, we'll try to see that. So you should be knowing these basic concepts. So halo orbit of Lagrange points. Then we would come to the technology portion. So in technology portion, we would cover first when we have to send something in space, you need a launch vehicle like PSLV, GSLV. But PSLV और GSLV को भी कौन चीज़ पावर करती है, क्या क्या चीज़ पावर करती है? There will be some engines. So, you should be knowing what do you mean by rocket engine. Cryogenic is a type of a rocket engine. So, you should be knowing about engines in general. So, here we can discuss jet engine first, and then we can discuss about a rocket engine. And in rocket engine, nowadays you would keep on hearing about terms like cryogenic. And have you also come across semi cryogenic? Yes. So, we would try to see semi cryogenic. Does India have semi cryogenic engine? क्या इंडिया के पास सेमी क्रायोजेनिक इंजन है? हो सकता है, ये गेस वर्क। हाँ, हाँ। प्राइवेट एजेंसी तो अभी अभी नए नए आए हैं इंडिया में। सो स्काई रूट और अग्निकुल, दे हैव रिसेंटली कम अप, दे आर नॉट लाइक स्पेस एक्स. So they are at very very rudimentary stages. One achievement you would see that they have made a private cryogenic engine, but semi cryogenic engine is a more difficult technology. Even ISRO has not been able to develop. So you should be aware about this kind of situation. Where will we be using semi cryogenic engine? That also you should be knowing. So after you know the engines, then we can discuss about the different kinds of launch vehicles which India have. You would be aware about which launch vehicles are we using nowadays. Yeah, so we started with SLV, then we switched to ESLV, then we switched to PSLV, then we are moving or we are using GSLV. GSLV के बाद क्या होगा? GSLV में ही, so what you're mentioning is generations of GSLV itself. GSLV also has undergone evolution. So you call terms like GSLV Mark 1, Mark 2, Mark 3. As of now, we are using GSLV Mark 3 mostly. So that GSLV Mark 3 is often mentioned as LVM 3. But I'm asking what next? What after GSLV? Will we be using only GSLV? In future, you would be aware that India wants to have its own space station. India wants to land Indians onto moon also. So how will you be landing? Is GSLV capable enough to land Indians on moon itself? You would be, or ISRO is developing NGLV. सुना है NGLV के बारे में? So we will be discussing about NGLV. Parallelly, we are seeing development of SSLV and RLV TD also. RLV TD. We'll see what are these. So these are different generations of launch vehicles that will be used for different launch purposes. After this, we can move to the missions part and we can focus on some specific missions. Now, in missions, you would see the simplest type of missions are flyby mission. After that, orbiter type of mission. Then there are lander type of mission. Okay, lander. And the most difficult missions are human missions. Are human missions in news? Today also a human mission was in news. Which human mission was in news? आज कौन सा human mission news में आया? Artemis 2. Artemis 2 has been, or its launch has been delayed. It was supposed to be launched this week only. So its launch has been delayed. In Artemis 2, 10 or so, astronauts will go to moon. They will move around moon and they will come back safely to Earth. It does not involve landing on moon. But we would be seeing human landing again on moon. So human missions are in use. We are also having our own Gaganyaan mission. So we'll try to understand human missions in some detail. So in human missions, we can look at space station also. Are we trying to have our own space station? So we will look at this idea of space station. We will look at Gaganyaan mission and other missions also, which would be relevant for our exam. Like Artemis mission will also cover in the human mission itself. And then you have this current affairs notes, which would be mentioning things about these things only. Okay, so like satellites, some other satellites or some observatories, those are mentioned here. That also will be discussing. This would be the part of your basics. One more basic part would be after this that we can cover theory of relativity. In theory of relativity, we'll be covering special theory of relativity and general theory of relativity. Now, why these two theories are important? Because these theories were given way back in 1900, so 1905 and 1916, given by Einstein, and most of the theories, they are coming out to be true. So experimentally we are finding that they are coming out to be true. So here concepts like space time has been discussed, so you should be aware about these terms. What do you mean by space-time matrix? So here we'll be discussing about what do you mean by black holes, what do you mean by singularity, what do you mean by event horizon. Concept of gravitational waves was given by Einstein in this theory only, general theory of relativity. So again, this forms part of your basic only, and still you would see there are many other concepts embedded in special theory of relativity and general theory of relativity. Time dilation का concept सुना है आप लोगों ने? Gravitational lensing का concept सुना है? Yeah. So all those concepts you can understand if you understand the theories of relativity also. So these would be part of your basics, and then on top of that we'll do the current affairs. So you are aware that you will be tested also, so you'll be having tests, like just for polity you are having tests. So similarly for science and technology also we'll be having test. And what we can do, that after your test begins, let's say after 2 days your test would begin, so we would be discussing the test first, and then we can begin the class. Is that format okay for all of you? I think as of now, what was happening in polity was class was going on. After the test, there was a discussion video which was uploaded. Was that the format? Okay, okay. So I see some dissatisfied faces for this particular part. I will try to do as best as is possible. Let's begin with this particular part. Some of you, those who are not having any kinds of notes before, what you can do, you can message me so that I'll send you some class notes. So on Telegram, this is my ID. So you message me, I can send you the class notes. So this can become your base notes, and from here you can refer these basic concepts also. If you have already studied these things, then it would be like revision for all of you. And I see some printed notes you're already having. Okay, coming to Big Bang theory. So let me hear out what you know about the Big Bang theory. You would have seen this image for Big Bang theory. So when did Big Bang happen? So let's, okay, 13.8 billion years ago. So if I'm marking this as t is equal to now, what should I write here? Let's say this is the place where Big Bang happened. So what should I be writing? T. I know you have all read about Big Bang. Some critical aspects you should be aware. So when you say that Big Bang happened 13.8 billion years ago, so if t is now, so t would be 0 minus, अच्छा चलो वो उतना नहीं, so I just want to simplify for you, that we would write simply t as 0. It means what? With Big Bang, not only space started, with Big Bang, what also started? Time also started for our universe. So you should know this particular aspect, that with Big Bang, time also started, and not only space. So space and time are integrated. This you could see from this very idea itself. When Big Bang occurred, the world, we would say the world or universe, you can say, that would be a better word. So universe was just a small ball of mass, but it was very dense ball of mass and very small in size. And that particular object we call as what? Yeah. Some issue with the board? Hmm. Okay. Dark matter. So scientists have said that just before Big Bang there was something called as singularity. How do you think they have predicted that there was something called as singularity? कि हर चीज एक पॉइंट ऑब्जेक्ट से कैसे निकल कर आई होगी? By reversing it. What we are seeing, that universe is expanding, and universe is expanding at accelerated rates. So if you reverse it back, then you can think that everything would have come from a particular point object. That point object we are calling as singularity. After this, the world would have, or the universe would have started cooling, and after the explosion there would be many charged particles that would have been released. Protons and electrons would have been released. Some electrons would have started revolving around some of the protons. So if you have a proton here, if electron starts to revolve around it, which element are we forming? So hydrogen was formed in such a manner, and similarly helium would have been formed by similar process. So after the cooling process would have begun, some initial elements would have started forming, such as hydrogen and helium. So hydrogen is the first element in our periodic table, first element of the universe itself. What do you think would have formed first, stars or galaxies? First first you would see coming up of stars. So stars would have been formed first. Af- okay, so thank you, Siri. So after stars would have come, then galaxies would have started forming. You would have heard that most of the galaxies are spiral in nature. So you could see that spiral galaxies were formed. What are we seeing about distances between them? The distances between them is increasing. So the distances between the galaxies is increasing. So this is the basic idea that you can have regarding Big Bang theory, that universe started with Big Bang. So there are many other competing theories also. Mythologies have different kind of explanation. Indian mythologies have also different kind of explanation, but this is considered to be one of the most accepted theories with respect to origin of the universe. Universe is constantly expanding, and what is the rate of expansion? It is Hubble constant, or is it expanding at the speeds faster than speed of light itself? For universe we say in general that nothing can travel faster than speed of light. So any particle, any object that you would take would not travel faster than speed of light. But what we see for the universe expansion, that it is expanding at a rate faster than the speed of light itself. So what would normal theory of gravity say? Normal theory of gravity would have said, और जो न्यूटन के कॉन्सेप्ट्स हैं ग्रेविटी को लेकर के, what is the Newton's concept of gravity? Newton concept of gravity is quite simple. So he would simply say that if there are two masses, you know the formula, I don't want to bug you with the formula, and if the distance between them is r, so what does he say regarding gravity? Gravity is a force of attraction between two masses. It is more if the masses are closer. So if they are closer, the attraction force will be more, or if the masses are more, then also the gravity would be higher. But there would be limitation also. जैसे ये फॉर्मूला लिखते हैं ना, m1 into m2 by r square, ये फॉर्मूला आपने देखा होगा. किसी भी ऑब्जेक्ट का यदि मास जीरो कर दें, if there is a mass, if there is an object which has zero mass, then should it feel gravity? Let's say if there is an object passing around sun, but that object does not have mass, should it feel the gravity of the sun? According to Newton, it should not feel the gravity of the sun because it is product of the masses. But does that happen in reality? No. Gravity would affect something which is massless also, which is photon. So Newton's concept has limitations. So based on this limitation, we will see the concept of Einstein also. So if we apply Newton's law here, the galaxies should have come closer towards each other. Let's say this is galaxy 1 and this is galaxy 2. So by a simple logic of Newton's gravity, both these galaxies should have attracted towards each other and they should have coalesced. But is that happening? We are seeing otherwise. So why is it that the universe is expanding? there must be something stronger than gravity, and it must be opposite in nature to that of gravity. Gravity क्या है? Attractive force है. So it must be a repulsive force and stronger than gravity. What is that force that we call as? Not electromagnetism. So dark energy, yes. So that force which is responsible for causing expansion of the universe is dark energy. We don't know much about it, but at least we know this, that this is the force which is causing accelerated expansion of the universe. Is this part okay to all of you? Now moving to the composition part. Composition of universe. So we are drawing a Venn diagram here. Everything that we see that we can see is called as real matter. Is there a simple definition of a real matter? What is a real matter? So you and I are part of real matter. Earth is real matter. Sun would be a real matter. Will a black hole be a real matter, or will it be a part of dark matter? Dark matter. So what is real matter? What can we say? What is a real matter? Anything which follows, which has mass. Okay. There is something also called as dark matter, roughly around 27%. ये दोनों तो मैटर ही है, दोनों के पास मास है, तो फिर डिस्टिंग्विशिंग फीचर क्या है? Which is not visible. So is a black hole visible? Is black hole visible? So will I put black hole here or here? The black hole will be called as a dark matter. So you say that big stars, when they die, they can become a black hole. When? हाँ, okay. हाँ, those are dark matter. Yes, true. Black hole is real matter. Why? क्या ब्लैक होल दिख रहा है आपको? ये भी मैटर है, इसको भी डिस्ट्रॉय नहीं कर सकते. So very simple idea of what is a real matter. Anything which emits light or reflects light or interacts with light, that would be called as real matter. So anything which interacts with light, either it is emitting out light like sun. Sun is a star. Star are releasing light. Or moon. Let's say moon. Why we can see moon? Because it is reflecting light. Why you cannot see a black hole? Because it absorbs the light, but there is an interaction there. So it is absorbing, so it is an interaction. So anything which interacts with light, or we would say anything which interacts with electromagnetic radiation, is called as real matter. So even a black hole would be categorized under real matter. So every universe that you're seeing, or sorry, not every universe, every galaxy that you're seeing, and the stars and the planets and the moons that you're seeing, they would be part of your real matter only. So anything that you see, or mostly the things that you see, galaxies, stars, planets, moons, and everything on planets also, including us, would be part of real matter. So either they are absorbing light, they are reflecting light, or they are emitting out light. So those would be called as real matter. And they would be having, if it is matter, it would be having mass. If it is having mass, it would be also having gravity. Now what about dark matter? Why are we calling it as dark matter? We are calling it as dark matter because we cannot see. That is one reason. But that is not the important reason. The important reason is that it does not interact at all with electromagnetic radiation. Since it doesn't interact with electromagnetic radiation, or for example, it does not interact with light, so you cannot see anything that you can see. Why you can see me? Because light is falling on me, and that light is reaching your eyes. That is why you are able to see me. So you cannot see anything. if the light is not being reflected or emitted, or somehow it is absorbing the light around itself, so it is not interacting at all with light, so you cannot see. It means it is obviously invisible. If it is invisible, how do we know that it exists? It would be gravitational lensing, could be one phenomena. What is gravitational lensing? The bending of light by matter. Yes, so that would be the idea. So before that, scientists had tried to find out also a mass. Let's say total mass of a galaxy. For example, they would go for mathematical calculation of total mass of Milky Way galaxy, which is our galaxy. And when they summed up the masses of the stars, the planets, the moon, they found out that the gravity that they would be producing would not be sufficient to hold all the stars or the galaxy together. It means that to have additional gravity for our Milky Way galaxy, there must be something more within the galaxy. And what is that something more? Dark matter. And can you see percentage wise or multiple times, at least it is 5 times more than the real matter itself. So this one, dark matter, is providing what we call as gravitational scaffolding. So it provides gravitational scaffolding for your galaxies and for the universe also. So they are the ones which are creating extra gravity so that things can be held together inside a particular galaxy. Scaffolding का मतलब क्या होता है? Scaffolding, the temporary structures, when you build a building, so you see temporary structures of rods. जो पुराने टाइम पे बांस और बल्लियां यूज करते थे, अभी rods यूज करते हैं. That is called as scaffolding. So it is acting as a scaffolding to create the gravity to hold everything inside a particular galaxy. That is the idea of dark matter. But scientists do not honestly know much about dark matter. We don't know much about dark matter. We want to know about dark matter, but still we don't know much. We will see a mission for this one. Then around 68% is your dark energy. This also scientists do not understand well. Both of these together, they are part of what we call as dark universe. So how much percentage is the dark universe? 95% of our universe is dark universe, of which we know very very little. Dark energy, previously you would have mentioned that it is a force. So it is energy, it is a force which is opposite in nature to that of gravity. But will it be stronger than gravity? Yes, it is much stronger than gravity, and it is this energy which is causing accelerated expansion of the यूनिवर्स. आइंस्टीन ने ये टर्म नहीं दिया था, बट आइंस्टीन ने जब अपनी थ्योरी दी थी, जो जनरल थ्योरी ऑफ रिलेटिविटी है, उन्होंने एक टर्म मेंशन किया था. ही वाज आल्सो अवेयर दैट यूनिवर्स इज एक्सपैंडिंग, बट दैट फेनोमेना टू एक्सप्लेन ही यूज्ड द टर्म कॉस्मोलॉजिकल कांस्टेंट, but he did not mention the term dark energy. Dark energy, the term was coined quite later also. So this is the idea of the composition of our universe. Do we have anything to study about dark matter or dark energy? Do we have any mission to study dark matter and dark energy? Euclid mission. So there is one mission that you should be aware about, that is Euclid mission is there for studying about dark matter and dark energy. I guess it is mentioned on, do you have access to your PDF that you have got today? Page number 21. Page number 21, topic number 23. Page number 21, topic number 23. Can you read the Euclid mission from there? Okay, give it a read. Give it a read. Note where we have sent it also. कहाँ पे भेजा है? L2 of sun and earth. Okay. And also note the instruments. Instruments. So there are two instruments. VIS एंड NISP, ठीक है। और एक टेबल भी बना हुआ है, यूक्लिड वर्सेस जेम्स वेब का कंपैरिजन किया है। Okay, we'll study about James Webb separately, but here you can briefly see both have been sent to the same place. That is, both have been sent to the Lagrange point 2 of Sun and Earth. So, क्या advantages है that we will see little later. So, see, uh, can you compare? Can you see one common comparison point that Euclid? So, field of view is it can see an area larger than the James Webb telescope in one shot. So the objective of Euclid is to scan the sky and not to focus on a particular object. So it is like a scanner. And if you see James Webb telescope, it is a telescope which is focusing on a particular object and magnifying it to study the deeper parts of it. So this is the basic difference that you can see between Euclid and James Webb also. Okay, so यूक्लिड के क्या क्या इंपॉर्टेंट फीचर्स हैं जो आपके एग्जाम के लिए इंपॉर्टेंट हो सकते हैं? कौन सा एजेंसी है? Yes, so you should not get confused that it has been sent by NASA. It has been sent by European Space Agency. At which particular point? At L2 point. So it is sent at halo orbit of L2. So you can add that if it is not mentioned there. So it has been sent to halo orbit of L2. We'll see what are halo orbits of L2, but these are few factual things that you should be aware also. Then you can see it is slightly different from James Webb telescope, that it is not focusing on a particular object, it is rather scanning the sky. So it would scan one third of our universe to find out what? Dark matter and dark energy. So Euclid, if it comes, then you should know it is linked with what? Dark matter and dark energy. Both have been sent to L2 point. Why L2? We will see the reason little later also. So coming back to, now we can move to our galaxy, Milky Way galaxy. Here also a few concepts that you should be knowing. Our Milky Way galaxy is a spiral galaxy, but for understanding and for simplicity, we'll just draw it as a spherical galaxy. What is present at center of every galaxy? A black hole. Which type of black hole? So at center of every galaxy, scientists have predicted that there exists supermassive black hole. In history, you would have read that initially we were having Earth centric view. We said that Sun is revolving around Earth, but now we know that Earth is revolving around Sun. But the question is Sun revolving around anything? Around what? Yes. So stars in a galaxy, they would have a general tendency to revolve around the center of galaxy. So for example, if this is our sun or this is our solar system, our solar system is also revolving around our black hole. What is the name of our black hole? Yeah, good. So you are aware. So it is Sagittarius A. So this is the name of our supermassive black hole. So you should know the distinction between supermassive black hole and a normal black hole. We'll see that when we'll study about the concept of black hole and general theory of relativity also. So we are saying that at center of every galaxy there exists a supermassive black hole. Our solar system is some distance away from the black hole. This distance, again, numerical value is not very important, but the unit is important. How do we measure astronomical distances? What is the unit? Okay. So astronomical distances are measured using the unit light years. What do you mean by this? Distance traveled by light in 1 year. That would be called as light year. Kitna distance hai? Again, the number is not very important, but this is the value. 26,000 light years. So our solar system is 26,000 light years away from our center of galaxy. What is speed of light? So coming to basics of light itself. Speed of light, अच्छा चलो कुछ को याद है तो अच्छी बात है, नहीं याद है तो कोई फर्क नहीं पड़ता. Is this definition complete? In vacuum. Okay, so you are saying for a particular medium. So you are saying astronomical distances are measured with help of light. Why don't we use light as a unit to measure distances on Earth? Difference in medium. So on Earth we have different mediums. So in different medium the speed of light would change. So it cannot act as a unit or a standard unit to measure distances on Earth. And also light speed is very fast. So it would not be very relevant unit for Earth also. But the important explanation is that speed of light is not constant in every medium. Speed of light when it is coming from sun, it would be traveling at this speed. When it enters into Earth's atmosphere, will it get slowed down? Yes, it gets slowed down. When it enters into water, it gets further slowed down. Inside diamond, it would be the slowest. That is why you would have heard that refractive index of the diamond is highest, because inside diamond the light crawls actually. So for Earth, you cannot use light as a unit for measuring distances. But for astronomical distances, when you say the term astronomical distances, you are talking about astronomical objects, celestial objects, and the medium between them we'll assume to be vacuum. So the medium here we are assuming to be vacuum. That is why you can use light as a unit to measure astronomical distances. We'll see questions based on this. UPSC has already asked. So you should have such kind of clarity with respect to answering such questions also. Now moving to our solar system. Acha, when was our solar system formed? What is the timeline for this one? Roughly around 5 billion years ago. So our solar system was formed, or our sun was formed roughly 5 billion years ago. Now, if you say that sun is revolving around the center of the galaxy, how many times do you think it has made revolution, or how many revolutions has it made? Aware about this? Our sun has made 20 revolutions till now. That is, in 5 billion years, it has made 20 revolutions. And scientists are predicting that sun will make 20 more revolutions. And after that, sun will die. So future of sun is not very bright. Uh, why will sun die? When you say sun will die, what do we mean by that? Are you clear with that? We'll see what do you mean by when the sun will die. So this is the situation that our sun is in main sequence stage. We'll see the origin of sun also. So it is burning, and after some time it will stop, or the fusion in the sun will stop, so it will die. Why it will die, what will happen, that also we'll see. So coming to the next part. So solar system. What is the outermost layer of solar system called as? Solar system, Earth का नहीं, Kuiper belt outermost है. Oort cloud is the outermost. So let us say if this is sun, then the outermost layer is what is called as the Oort cloud. Do you think we have been able to reach to this part? Voyager 1 क्या Oort cloud पे पहुंच गया है? It has crossed one particular boundary. That is true. That boundary is, what is this boundary called as? Heliopause. Then there comes Kuiper belt. ये सब पढ़ा होगा बचपन में, नहीं पढ़ा? Because I see my nephews, they are studying these things, and they are surprised that I don't know many of these things. So they say, they are saying to me, चाचू आप साइंस एंड टेक्नोलॉजी के टीचर हो, आपको ये क्यूपर बेल्ट भी नहीं पता है, वुड क्लाउड भी नहीं पता है. They know much more deeper about Kuiper belt. Probably they are in different generation. So you have this Kuiper belt, then you have the planets Mercury, Venus, Earth, Mars, and between the outer planets and inner planets we have a belt. Which belt is this? Yeah, so this is your asteroid belt. I'm just writing the initials. So this is your asteroid belt. Now, can you tell me something about Oort cloud? What do you know about Oort cloud? What would this boundary be of sun? So here is our sun, and this is the extreme boundary of our solar system. What do you mean by extreme boundary of our solar system? Beyond this, what will you not feel? Effect of gravity of sun. So when you say Oort cloud, it is the boundary of sun's gravitational influence. Beyond this, you will not feel the gravity of the sun itself. Then what about heliopause? What is this boundary now? Heliopause कौन सा boundary होगा? When you see the term helio again means sun only. So it is the boundary of the light. It would be the boundary of the charged particles that come out from the sun. So sun is continuously releasing out charged particles, and those charged particles is traveling in our solar system. It cannot travel beyond this particular boundary. So this is the boundary of the charged particles coming out from sun. When charged particles flow, yeah, chalo, thank you. Charged particles such as protons and electrons, when they move, for example, in a wire, what is moving? Electricity. When you say electricity, what is electricity? Flow of electrons. So when electrons or charged particles they flow around themselves, they produce what? Magnetic field. So a flowing charged particle produces magnetic field. It means these charged particles which are flowing in the space or in the solar system, they would be creating a magnetic field for the sun. This is what is called as magnetosphere of the sun. So these charged particles are creating magnetic field of the sun. Or we can also say that heliopause is boundary of sun's magnetic influence. It is boundary of sun's magnetic influence. When you mentioned about Voyager are instruments, or you can say spacecraft, the most distant spacecraft which humans have ever sent. They have been able to cross what? They have been able to reach here, or they have been able to cross heliopause. So Voyager 1 and Voyager 2 are here. They have not been able to cross the Oort cloud, and it could be very very difficult to actually cross the Oort cloud also. You might not have the fuel to go beyond the Oort cloud. How do you think it is possible to launch something from earth and to go to so far place? सोलर और न्यूक्लियर, और न्यूक्लियर पावर होगा तो वो उस स्पेस में वहां तक पहुंच जाएंगे. Radioactive elements energy is needed, that we'll see. How do you think you would be sending Voyager? किसी की ग्रेविटी का हेल्प लगेगा आपको? Jupiter's. So this is what we call as gravitational assist. So we would be using the gravities of the larger bodies to send something into deep space. That phenomena is called as gravitational assist. We'll see what is this gravitational assist phenomena. So to go deep in space, you would need gravitational pulls of other bodies also. Now coming to the sun part itself. So we can discuss about sun. How do you think a star is born? Birth of a star. ये पढ़ लिया होगा आप लोगों ने. So, what is the famous thesis? Nebula hypothesis. What is nebula? It is a cloud of, cloud of mostly gases and dust. What would happen after this? Gravitational compaction hoga. So there would be some objects which would start attracting the neighboring objects. So it would start to grow. So the nucleus would start to grow and gravity would start to compress. So you would see gravitational compaction happening. So gravity is compacting everything. Due to gravitational compaction, imagine if there are hydrogen molecules here. There are hydrogen molecules. You are reducing the distance between the hydrogen molecules. What will happen to the temperature between the hydrogen molecules? It will tend to increase. So this central part would start to become hotter and hotter. So you are compressing everything. Gravity is actually compressing everything. So it would become hotter and hotter. So this stage we call as the protostar stage, when it has become very, very hot. But fusion has not started at this stage also. After this stage, what could happen? Because of intense gravity, the hydrogen which is present inside this protostar could start to fuse. So hydrogen would start to fuse. कितने हाइड्रोजन फ्यूज करेंगे कि आपको हीलियम मिलेगा? दो हाइड्रोजन फ्यूज करेंगे. Hydrogen mass is how much? Yeah. So you have to fuse 4 hydrogen to get 1 helium nuclei. So there is a fusion process that will begin. Because of this fusion, there will be a release of energy. Why there is a release of energy? That also we'll try to understand. So after protostar stage, the fusion will begin. The fusion will stabilize. So fusion after some time stabilizes. When it stabilizes, then we say that the star is in main sequence stage. So sun is at this particular stage. Sun is at, is it not visible from that side? Okay. Oh, because of the pillar. You don't have a screen that side, no? Okay, so what I'll do, I'll prefer to write it this side, or I can just if you study evolution, you would have seen giraffes. तो आपका neck वैसा ना हो जाए. So what we are saying that gravitational compaction will happen, a protostar will be formed, and then fusion of hydrogen will begin. Because of fusion of hydrogen, lots of energy will be released. Why energy is released, that also we'll try to see. And then we would say that the sun or the star is in main sequence stage. So it is emitting out light and energy continuously. But if the fusion has not stabilized, what are those stars called as? Yeah, so there are young stars. Young stars where fusion has not stabilized. If fusion has not stabilized, those are called as Cepheids. So if the fusion has not stabilized, those are called as Cepheids. If fusion has got stabilized, then we will call it as a main sequence star. After main sequence star, the star will die. Why the star will die? Because the fusion would stop. Why the fusion would stop? That also we'll try to understand. So what is powering our sun? So you are seeing that it is the fusion process which is powering the sun. But what condition is required to cause fusion? And where does fusion take place inside sun? So fusion, for fusion to occur, a state is required. Which state? Plasma state is required. What do you know about plasma state? Plasma is called as the fourth state of matter. First three states you would be aware: solid, liquid, and gas. What is plasma state? Plasma state is superheated matter. So plasma state simply means superheated matter. Again, I'm writing this side. Okay, so I'll take a fresh board. So how do we produce plasma, or what happens when we produce plasma? If you heat hydrogen, or if you superheat hydrogen, hydrogen will break into ions. So hydrogen will split into protons and electrons. This is what we are calling as plasma. And if you have sufficient pressure and temperature on it, then you can cause fusion of protons also. So in order to cause fusion of hydrogen, so we have said you need what, 4 hydrogens to cause fusion. 4 hydrogens will fuse to form helium. But what is the problem when we go for fusion? When we try to fuse hydrogen, let's say there would be electrons, there is proton here, there is repulsive forces would be there. So if I try to fuse these nucleuses together, then the electrons would not allow them to fuse. Why? Because electrons are same charge particles, they will repel each other. So fusion will not be possible. What we will do when we go for plasma state, we rip off the electrons. So we get rid of the electrons. So now we are having what? 4 protons, which we want to fuse. But again the same problem. Again the same problem, that if you're trying to fuse 4 protons, they are also same charge particles, they will also repel. So how will fusion happen? Fusion can happen only when very high pressure and very high temperature is applied. So under high pressure and temperature, then you can cause fusion of this, because it can then overcome the electromagnetic repulsive forces between the protons. But where is the energy produced from in a fusion process? The energy is produced from, if you take sum of the 4 hydrogen. So should I be saying, if I sum up the masses of these 4 hydrogen atoms, it should be equal to the mass of helium atom? But is that happening? That doesn't happen. If you look at mass of 4 hydrogen atom, it would be roughly around some unit, and this one roughly around EMU. So what is happening? Sum of 4 hydrogen atoms is more than the atomic mass of helium. So when we go for fusion process, there is loss of mass. That loss of mass is converted into energy, given by the famous equation जो आपने अपने physics lab में देखा होगा. Energy is equal to delta mc square. So delta m is the loss of mass, c here is speed of light, जो आपने value देखा है, c is equal to 3 into 10 to the power 8 meters per second. So if you plug in those numbers, you can get the energy value for hydrogen fusion. So if you just fuse 4 hydrogen atoms, you can power or run this 60-watt bulb for more than 100 years. That is the amount of energy that is released by fusion. So fusion is considered to be the most energy efficient process for energy production. So stars are powered by fusion. We are not able to do that fusion on earth. We are trying to do that. We will see that in fusion or nuclear technology also, that what are we trying to do. But this is the source of power of stars. And the fusion does not take place in all part of the sun. Fusion takes place only in the core part of sun. And you would also be aware that the temperature inside sun is not sufficient to cause fusion of helium. सन के कोर में अराउंड 15 मिलियन डिग्रीज फ़ारेनहाइट का टेम्परेचर होता है. दैट मच टेम्परेचर एंड प्रेशर इज नॉट सफिशिएंट टू कॉज फ्यूजन ऑफ helium. So what is the fuel for sun then? The fuel for sun is only hydrogen. So hydrogen is combining to form helium. What is the composition of sun? What is the sun mostly made up of? So it is mostly gaseous. So it is made up of hydrogen. Roughly around 75% of sun is hydrogen. Then it is composed of helium, roughly around 23%, and some heavy metals, which would be around 2%. But is this ratio going to remain constant, or is it changing every second? This ratio is changing every second. Why? Because the hydrogen is getting converted into helium. So would there be a point when this becomes zero? When all the hydrogen gets exhausted. So hydrogen is the fuel for our sun. If hydrogen gets exhausted, then we would say that sun will die. And this scientists have predicted that it will take around 5 billion years from now. So thankfully we will not be here to watch this kind of phenomena. Do you think earth would be existing before this situation, कि सन में फ्यूजन 0% का हम वेट करेंगे या अर्थ पे लाइफ बचेगी? Earth would have got destroyed much before from life perspective, because the amount of energy that we are receiving would have reduced much before. So climate change पहले ही आ चुका होगा. So everything would have died much before the sun dies. So earth life would have extinguished much before the sun dies itself. Will not be here to watch this scary thing. And everything comes with sunset clause, you know. आपने पढ़ा होगा कि sunset होता है सभी में. So this is the composition of the sun. This is how our sun is powered also. Now, what you have to imagine about sun or activities of sun. Activities of sun you can understand from a particular phenomena which is called as solar cycle. What do you know about solar cycle or sun cycles? Solar cycle. For earth, you would be aware that the north, so earth has a magnetic north pole and a magnetic south pole, and we know that the magnetic north pole will flip and become magnetic south pole and vice versa. But for earth it takes thousands of years, probably 40,000 or more than that also. But that phenomena, so sun is also a magnet. Sun is also having a magnetic north pole and a magnetic south pole, but the flipping of the poles in sun takes place very frequently. It takes place in every 11 years of time. So that period is called as the solar cycle. So sun has a solar cycle of 11 years, and in between those solar cycles you will see phases of solar maximum and solar minimum. I guess this explanation is given in your notes also. So can anyone get to the page number? Page number 25. It should have been mentioned before, but it is okay. So you can read from here, or you can add here if. Yeah. Topic number 25 in your notes. Solar maximum and solar cycle. Topic number 25. So in between this period, you would see phase of solar max and solar minimum. What do we mean by solar max and what do we mean by solar min? Before that, you need to understand concepts like what do you mean by solar flares. You will see terms like solar winds. You will see terms like coronal mass ejections. You will see terms like sunspots. Yeah. So are you clear with all these terms? What are solar winds? Solar winds. So we have said our sun. So you have to always imagine sun is a ball of. It is a ball of plasma. So sun is a ball of plasma. You have to always imagine like that. So it is containing charged particles, that is protons and electrons. And what it will do to these charged particles? It will keep on throwing out in our solar system. So when it continuously throws out these charged particles in a very certain manner, then that type of phenomena we call as solar winds. So it continuously keeps on releasing charged particles. So sun, you are aware that it is source of heat and light. So when you say light, so it is sending photons, but when you say heat, so it would be releasing these charged particles along with some energy. So those are called as your solar winds. What do you mean by solar flares? So there is here the term here is it different from winds? Flare means sudden release. So there is sudden release of heat and energy, and it could be very, very intense also. So that is what is called as solar flares. and it depends on which from which part of the sun it is coming out. So you will also hear a term CMEs, coronal mass ejections. We'll see the layers of sun, but you should be aware that the outermost layer of sun is called as corona. So if the charged particles are released from the outermost layer of sun, then that would be called as CMEs, coronal mass ejections. These could be coming out from other parts also of the sun. So if it is coming out from the corona part, we'll call it as CMEs. Then what are sunspots? What are sunspots? Where do we see that in sun? Acha, is the layer of sun also mentioned in your notes? Layer of sun piche. Diagram is mentioned there. I'll just draw that diagram for all of you here so that you can visualize. I guess you have studied this before also. So we would say there is one inner layer and there are outer layers. So if I take this portion, what is the innermost layer that we see? The core. Then there is radiative zone. Then there is convective zone. So the inner layer has 3 layers, and then after the convective zone, which zone should we be seeing? Yeah, so this layer is the photosphere. After the photosphere we see a thin layer which is the chromosphere layer. And then the outermost layer, this layer that you are seeing, this layer we'll call as the corona. Corona literal meaning is crown. We don't have to know about each of the layers, but at least some idea you should be having. Core, we have already said where fusion is taking place. So core is the place where fusion is taking place. Do you also realize this, that the pressure and temperature will be maximum at the core? So this is the place where fusion is taking place. So pressure and temperature is maximum here. The temperature roughly around would be 15 million degree Kelvin, or to a certain extent you can say it also in Fahrenheit. What will happen to the temperature as you move away from center? It should decrease. So the temperature should drop. So the outermost layer should be the coldest layer, but it is not. So which is the coldest layer of sun? Photosphere is the coldest layer of the sun, and its temperature would be in few thousand degrees Fahrenheit. So this is the coldest layer of the sun. After that we see that the temperature starts to pick up. So the temperature would increase here, and corona would have a temperature of about 2 to 3 million degrees Fahrenheit. We don't know the reason yet, that why corona is becoming hotter than the previous layers, but we know that this is happening. Photosphere is the coldest layer. Yeah, sunspots you will see in photosphere part only. So when you say you see the sun, the surface of the sun, sun is a gaseous object. It does not have a surface. What you are seeing, what appears to be red or oranges in color, is the photosphere. You cannot see the chromosphere part, you cannot see the corona part. Okay, so I'll just mention, so you can read from there also. I'll just mention. So this is the core part. After the core part you have the रेडिएशन जोन. रेडिएशन आपने कॉन्सेप्ट पढ़ा होगा स्कूल में. रेडिएशन क्या होता है? ओके, conduction, convection and radiation, these are few heat transfer mechanisms. कंडक्शन में कैसे हीट ट्रांसफर होता है? हीट विल ऑलवेज ट्रांसफर फ्रॉम हायर टेम्परेचर to a lower temperature by direct contact. So conduction would be by direct contact. चाय बना रहे हो आप, केतली टच कर दी, तो केतली का हीट आप में आ गया, that would be conduction. What is convection? जो वाटर में हो रहा है जब चाय बना रहे हो. So the lower layer is getting heated up, it goes to the upper layer sinks. That is what is called as your convection. In atmosphere also the same phenomena happens, convection currents. What is radiation? you don't need a medium. So heat will transfer from one place to another place without the need of a medium. Like you are receiving energy or heat from sun without, so sunlight is mostly traveling in vacuum only. So that is called as radiation. So this zone that you're seeing, radiative zone, so there is no transfer of particles here, but heat is getting transferred to the upper layer, so through radiation to the radiative zone. Convection zone, it is, so the lower layer gets heated up, it rises and then it falls. So it is transferring heat by convection mechanism. Then there is another layer which is the photosphere layer. This we call as the surface of the sun, and this layer has what we call as the sunspots. What do you mean by sunspots? What are sunspots? These are colder sections of sun. If the temperature of this one is 5500 degrees Celsius, this one temperature would be around roughly 3500 degrees Fahrenheit. So it is the colder sections of the photosphere. Why it is colder? Because the magnetic field lines here are much stronger here. So magnetic field lines are very concentrated here at these positions, so they are more colder. Also, the number of sunspots is not static. Number of sunspots is dynamic. It means that the number could sometimes be more, sometimes it could be less. Are you getting the idea then? So coming back to this situation, Acha, before we get to the explanation part, then we have this layer, chromosphere. It is a thin layer, but it has the strongest magnetic layer, or it is the strongest magnetic layer. It is this layer which is actually controlling the flow of plasma. So if you have to control flow of charged particles, you can control it by magnetic fields. So this is the layer which is actually controlling the flow of the plasma part of the sun. Then comes the corona part. Corona part is the outermost layer. It is the least dense layer. That is also obvious that it will be the least dense. सबसे dense layer कौन सा होगा? Core सबसे dense होगा. The outermost layer is the least dense layer, and this layer is not visible to us by naked eyes. We can see it during eclipses. So during eclipses, when the sun major body is blacked out, then we can see the outer layer. So then we can see the corona and the chromosphere. So these two layers are not visible to us. Have we been able to touch sun's corona? Has there been any object which has gone too close to sun to touch sun's corona? Which mission? Parker mission. So Parker mission has been able, Parker mission has been able to touch, stop, press हो सकता था, but I am aware we had this issue in Rouse also. Parker mission has touched sun's corona for a very brief period of time, and then it moved out. So it is having the feat that it is the object which has gone closest to sun. Parker mission has gone closest to sun. Parker mission is also mentioned in your notes. If you want, you can read some lines about that. आदित्य के बाद आपके पार्कर का एक टेबल बना होगा, हाँ, पेज नंबर 4, 27 में भी है, हाँ, Parker Solar Pro, but you can get to page number 4. There you will get a more detailed table about Parker. So in Parker 4, page number 4, topic number 2. So can you see that last block? World's closest ever mission to sun. So Parker has been the closest mission. Then Aditya that we have sent, it is at which point? Lagrange point, L1. Then there is Soho mission. Soho mission is an old mission, but that was also sent to your Lagrange point 1 only. But this one is just hardly 1.5 million kilometers from Earth. Aditya and your Soho mission. So this has been the closest object. Parker mission, why the name Parker? It was named after Eugene Parker. Eugene Parker was the first person who theorized the concept of solar winds. So this understanding of solar winds, solar flares that we have, was given by Eugene Parker. So in his honor, we have kept that name Parker mission. Eugene. Newman Eugene Parker, and he theorized the concept of solar winds. So, in honor of his contribution, we have kept this name of the mission, Parker mission. You can study the design aspect also. इसका design इसमें आपको detail में नहीं दिया, but try to read about the design. What, so if you are going very close to sun, are you getting very close to sun? Are you touching sun's corona? Yes, we are touching sun's corona. Then how it is withstanding such kind of heat? That is a question. So that, write that question for yourself. How it can withstand such heat? कौन सा material use करा है? That you can find for yourself. How it is withstanding the heat? How did it withstand the heat of sun? Which material was used? Okay, Aditya mission, you are already aware, but this you can study a little later. Now, coming to this conceptual aspect, solar max and solar. So you should be knowing about such materials. Uh, so you can find solar max. Now, coming back to this particular situation. Now, when you say sun is undergoing a solar cycle, it will experience solar maximum and solar minimum. What do we mean by solar maximum? Yes. So when you say solar max, it means that sun is highly active. Sun is highly active. It means that it is sun is releasing too much heat and energy in those phase or in this particular phase. So sun is very aggressive in this phase. So I can definitely say that solar flares will be more, CMEs will be more. But what about sunspots? Number of sunspots. नंबर ऑफ सनस्पॉट्स कम होंगे ज्यादा होंगे सोलर मैक्स में? ज्यादा होंगे, क्यों? That is the logic. So the number of sunspots will be more because sun is giving out energy. So there would be sections of the sun which would become more and more colder. Okay, so mass or energy has to remain constant. So if it is giving out energy, there would be more sections which would be colder now. So you can remember a simple correlation that during solar max, the number of CMEs will also increase and number of sunspots would also increase. Is that simple for you to understand or remember? Solar min में इसका opposite. So during solar minimum, there will be minimum number of CMEs, minimum number of solar flares, minimum number of your sunspots also. However, aberrations होते हैं. So ऐसा नहीं होता है कि perfectly हम लोगों ने ये सोलर साइकिल ढूंढ लिया है और हर 11 साल के बीच में सोलर मैक्स आता है. कभी कभी मिन पीरियड में भी सन की एक्टिविटी ज़्यादा होती है. So we don't know many phenomena of sun because sun is very very dynamic in nature. And when was the last solar max? Last solar max? This you have to find then. When was the last solar max? So अगले 11 साल में फिर वो solar max बदलने वाला है. So aware about when was the last solar max? So try to find it out. हाँ, सरकार से भी लिंकेज है. किसी का तो अच्छा टाइम चल रहा है. So linked to the activity of sun, you should also understand the concept of magnetic reconnection. We have established that sun is also having magnetic field, and we have also said earth is also having magnetic field. So will the magnetic field of sun and different planets, if they are having magnetic field, will they interact with each other? Yes. Yes. So that is a fundamental phenomena. That phenomena we call as magnetic reconnection. So what do you mean by magnetic reconnection? It means that the magnetic field of sun and the planet interacts explosively to transfer heat and light. So if you want to write a simple definition, you can just mention this one. For those auroras पे notes में नहीं है. But you would be aware a question was made in mains also on this particular topic, auroras. Okay, so I'll just draw a very basic diagram so that you remember what happens in case of auroras. So imagine this is sun. Sun is releasing out these charged particles, and if this is earth, earth also has magnetic field, and we draw the field lines. in some manner like this. The magnetic field creates a magnetic shield, a tear shaped magnetic shield. So this is the magnetic shield of. So when you say auroras, what do you mean by auroras and why they happen? So for auroras to happen, there are two conditions that are required. What are those two conditions? First, that the planet must be having what? Magnetic field, and it should have atmosphere. So these are two basic conditions that is needed for auroras to be formed. So what is the magnetic shield of Earth doing? So the magnetic shield, it deflects away most of the charged particles coming from the sun. So but it acts like a funnel so as to send the charged particles towards the polar regions, and then they form this auroras. So these charged particles, they are forced or they are funneled towards our poles. So it then enters into our atmosphere. When it enters into atmosphere, so you can imagine these are electrons and protons which are entering into our atmosphere. So will our atmospheric gases be affected by these moving electrons and protons? Yes. So atmospheric gases will react with these moving electrons and protons, and then they would be producing colored night sky. That phenomena is called as auroras. So you will start seeing here auroras. In northern hemisphere we call it as aurora borealis. In southern hemisphere we call it as, yeah, so in southern hemisphere we call it as aurora australis or southern lights. So this is the phenomena of auroras. It is part of magnetic reconnection. So do you think all planets have auroras? हाँ, किसका नहीं है? जिसका एटमॉस्फेयर नहीं है उसका नहीं होगा. Which planet has the strongest auroras? Jupiter has the strongest aurora. So Jupiter has the strongest magnetic field, and Jupiter has the thickest or densest atmospheric layer. So Jupiter has the strongest auroras. Do try to find out which planet does not have auroras. Magnetic reconnection you can write if you want. It is a fundamental process. It is a fundamental process in which magnetic field of sun interacts with magnetic field of planets. Magnetic field of sun interacts with magnetic field of planets to explosively transfer energy and light. To explosively transfer energy and light. It is this phenomena which is responsible to cause auroras. It is this phenomena which is responsible to cause auroras. Now let us look at some aberrations also. Is it necessary that auroras will always take place in the poles? Can it occur in other part of the world also? How? तो आपने लद्दाख मेंशन करा, सो लद्दाख में देखने को मिला है, तो कैसे लद्दाख में कैसे आएगा फिर? गैप्स इन द एटमॉस्फेयर. हाइट ज्यादा है, तो लद्दाख से भी हाइट बहुत ज्यादा है, तिब्बत चले जाओ. Is it about height? Magnetic. So there is linkage of magnetic shield and where the sun is it in its solar cycle. If sun is in solar max period, if it is in solar max period, could it be possible that it can eject out more mass, or there could be more CMEs that are ejected out? So it could be possible that more of charged particles is released here, or there is sudden burst of energy, and it could cross through the magnetic shield of Earth, and then it could reach to other parts of Earth also. So then you can observe auroras in other parts of the world other than the polar regions also. So during solar max period, this could be possible. And have you observed this kind of phenomena before also? Can these solar flares be detrimental? Okay. हाँ, PYQ में क्या क्या थे, क्या क्या रीजंस हैं, क्या क्या चीजें कर सकता है सोलर फ्लेयर्स? ओके। सारे फॉरेस्ट में फायर लग सकता है? It was an option. Acha, we'll see that question. But let us try to analyze this particular aspect. So, what would be the implications of solar flares, extreme solar flare cases? So, can solar flares destroy the satellites which are present in space? Yes. Can destroy GPS navigation system? Can it be detrimental to astronauts which are in International Space Station? Yes. So anything which is in space that we have sent could be jeopardized because of solar flares. Can it also compromise communication system on Earth, especially aeroplanes flying in the polar regions? Could that be affected? Yes, communication systems can be disturbed. What can happen on the surface of Earth? When you talk about grid, power grids, what are power grids? Power grids, these are grids which are sending electricity, or electrons are being sent here. Electrons are charged particles. So when sun would be sending out these charged particles, it can disturb the grid system of Earth also. So a grid system can also be destroyed. Can it also cause forest fires? Can it cause forest fires? Yes, it can cause forest fires, but not in all places and not across the whole globe. So it can ignite a fire, but for holding the fire, you need other supporting conditions also. So you need that there is a combustible material, the atmosphere is such, there is no rainy or there is no rain there. So only then only combustion can take place, or forest fire can take place over much of the earth. Can it cause tsunami? There was this particular option. Can it cause tsunami? Why it cannot cause tsunami? Tsunami is caused by what? By plate tectonics. So earthquakes. It is caused by earthquakes underwater or under oceanic plates. And do you think all earthquakes under oceanic plates lead to tsunami? No. Is there a mathematical value or a numerical threshold that it should be crossing? Yes. What? At least 6 on Richter scale. So the earthquake should take place in oceanic plate. It should be more than 6 on Richter scale. Then only it can produce tsunami. So solar flares cannot change plate tectonics. So it can definitely cannot cause tsunami. That was the question that was asked. Elon Musk satellites got fried because of solar flare. That is why this was in news, and question was also made that particular year. So you should be aware about this phenomena. And we have already said that not all planets would be having auroras. You need two conditions. One is magnetic field, and the other is atmosphere. Magnetic field is important because it acts like a funnel. So it is sending the charged particles towards the pole. What is this particular belt called as, which receives the most charged particles from sun? This is called as Van Allen belts. So this is the part of the shield which is receiving most of the charged particles coming from the sun. So most of the charged particles do get trapped here, so it gets heated up here, and then the other charged particles are then sent to your polar areas also. Coming to next part. So we have briefly discussed about sun. We can then discuss about basics of planets. Aja, since we have done sun, what we can do, we can also look at the missions of sun. Like in your sheet, it would be mentioned Aditya L1. Aditya L1. So topic number 2, page number 2. So before we get to planets, Aditya. L1 we'll understand later, but other aspects you should be knowing for Aditya. Why Aditya keeps on coming in news? क्यों न्यूज में था सोलर ऑब्जर्वेशन के लिए? Because in recent past we were able to place it in halo orbit of L1. That is why it was in news. We'll see what is halo orbit. But can you read about Aditya? Any unique thing that you are aware that is mentioned here? Hmm. Objective क्या है इसका? Is it studying interior of the sun? Can you see it is studying the outer layers? So it is studying photosphere, chromosphere, and corona. It is not studying core. It is not studying your radiative zone and the convective zone. So it is studying or focusing on the outer layer. Then also it is trying to understand the principle of coronal heating. So this is a common phenomena that you'll see, that we scientists do not understand that why the corona is getting hotter. So all solar observatories, you will see that they would be trying to understand this particular phenomena, that is coronal heating. Then other objectives have been mentioned: solar wind acceleration, coronal mass ejection, solar flares, solar magnetic fields, and particle fluxes. Monitor space weather. When you say space weather कौन determine कर रहा है? Sun determine कर रहा है. So by studying sun you can understand the space weather. So space weather for solar system is being determined by our sun itself. The Lagrange points are mentioned. We'll study Lagrange points separately, but if you are already aware, what is the advantage of placing it at L1? Fuel save करता है और अनइंटरप्टेड व्यू मिलता है. क्या ये पॉइंट हमारे शील्ड के अंदर है, मैग्नेटिक शील्ड के अंदर या बाहर है? So is the L1 point within our magnetic shield or outside of it? Outside? Acha, we'll see. Okay. Because we have to discuss Lagrange points. Since we haven't discussed Lagrange point, for those who are not understanding Lagrange points, then I'll discuss, then I'll declare. Okay, so instruments के नाम लिखें. UPSC generally has a habit of asking the names of the instrument. So you can just go through the names of the instrument. And but the name of the instruments you can see one is for studying corona. So coronograph. Can you see coronograph? Then we are trying to study the photosphere and chromosphere, तो near UV वाला चाहिए. Then we are also having soft X-rays. You can study others also. You can look at the table then. Aditya, Parker, and Soho. So can you see similarity between Aditya and Soho? What is the similarity between Aditya and Soho? Both have been sent to L1 point. So sun observatories, you will see that they are generally sent to Lagrange point 1. So this you should note. Both have been sent to halo orbit of L1. Both the distance is same. And Soho, one objective that you can see would be different. That is, it is also trying to study the interior also. It is also trying to study the corona part, solar wind, and helioseismology. So seismology means is it affecting the sun's surface also, or the so-called surface. So this is with regards to sun. और लास्ट में आपके सन के भी मिशंस दिए होंगे लास्ट पेज में. What was the page number? Yeah, page number 27. So in page number 27, can you mark out some of the recent missions? टेबल में लास्ट दो जो रोज हैं. यस, प्रोबा 3 एंड पंच. प्रोबा 3 एंड पंच. सो प्रोबा किसका है? European Space Agency. It is an active one. Why it is relevant for us? Because we sent it. So using ISRO's PSLV, we have sent this one. It is world's first precision formation flying to create an artificial eclipse. So proba, you should be aware that it was for sun. It was sent by ESA, but we have used our launch vehicle. Punch, you can see it is upcoming. So it will be of NASA, and they are trying to find out the link between corona and solar wind. So we are still not understanding the corona, why it is getting heated up, how winds are being produced. So there are many missing links that we are trying to understand by this particular mission. There would be more future missions. जो यहाँ पे मेंशन नहीं है, like you should be knowing about Muse mission, Muse and Helioswarm. For this, go to NASA's website, go to Sun, and in Sun you would get exploration, and do give it a read about Muse and Helioswarm. These are future missions to Sun. You just have to find out what are objectives. What are objectives of Muse? What are objectives of the Helioswarm mission? And you can add it to this table itself. Okay. So these are few missions which would be relevant for our exam purpose. So Proba 3 I have seen in many test series they have been asking, Punch they have been asking, so you should be aware. Parker we have already discussed, Aditya we have discussed, Soho we have discussed. Why Soho becomes very very important, or yeah, grandfather mission, because it was sent in 1995 and it was supposed to end its life by 1998, but for 3 years only. It has survived for very very long, so its mission period has been extended till 2025 and probably it is still serving. That is why it is of great interest, and it has video recorded Sun. You can see video recorded by this one you can get on YouTube. So I'm not sharing it here because sometimes IPR issues are there. So at home you can watch that video of observation of Sun by Soho. So you can see the activity of the Sun. Is Sun spinning also on its axis? Do you think Sun is spinning on its axis? What is the direction of, now coming to then planets? We'll discuss it here then. Coming to planets. What is IAU 2006 criterias? Okay. It should have cleared its own orbit. Has Jupiter cleared its own orbit? Jupiter कर पाया है? You're missing out a catchword there. Similar sized, yeah. So Pluto for very long was categorized as planet, but in 2006 we removed it out of the list of the planet. Now we have three criteria given by International Astronomical Union. The first criteria is that a planet must orbit a star. So the planet must orbit a star. In our case, it is Sun. Second criteria is that it should have enough mass so that it has, yes, it has shaped itself. It has shaped itself into spherical shape. So it should be having spherical shape. Pluto has this Pluto meets this criteria also. Pluto meets this criteria also. Then what is the third criteria? Third criteria is that it should have cleared its orbit. There should be no similar sized objects. There should be no similar sized objects in its path around Sun. There can be smaller bodies but not similar sized body. आपने पॉलिटी में पढ़ा होगा ये कॉन्सेप्ट. कौन सा कॉन्सेप्ट है? Sovereignty. No, sovereignty, there should be no two power centers, so it should be the whole or sole power center. So it should be the largest object in its orbit around the Sun. So Pluto fails to meet the third criteria. And also we say that Pluto has a highly elliptical path. That is why we would also say that it is, we have checked it out of the list of the planet. But the real reason was actually practical, because after 2006 we started finding too many such objects which are orbiting Sun, which are having spherical shape. So what should we do? Should we keep on increasing the list of the planet, or should we have a different criteria? So we came up with this kind of criteria so that smaller objects can be categorized differently. So we now call Pluto as a dwarf planet. How many dwarf planets are there? कितने? 4, 5. Wikipedia, the list is long, but you go to NASA's website, NASA would say that we are having 5 dwarf planets. So find out the name of the 5 dwarf planet. One you already know. And is it necessary that the dwarf planets would always lie in the Kuiper belt? Because Pluto, we know that it lies in Kuiper belt. So all dwarf planets, are they lying in Kuiper belt? No. Which one is lying in the asteroid belt? Ceres. Ceres is lying in the asteroid belt. So you should be knowing the names of the other dwarf planets also, just for namesake itself. हाँ कौन कौन से हैं? हाँ, so revise these things. Now, with respect to revolution and rotation of planets, so for our solar system, we have a direction which is we call as prograde and retrograde. What is prograde direction? So circular bodies, they can have clockwise direction, clockwise movement, or anti-clockwise. So prograde means what? Clockwise or anti-clockwise? Prograde is anti-clockwise, or west to east direction. So similarly, you can then understand retrograde. Retrograde would be, yeah, east to west or clockwise direction. Now the question is, what is the direction of movement of all the planets? Direction of movement of the planets with respect to revolution around sun. सबके प्रोग्रेड है रेवोल्यूशन? नो, घूमता है अपने एक्सिस पे कि सन के अराउंड? All planets are revolving around sun in prograde direction. So the direction of revolution of all the planets, all the 8 planets, is same. That is anti-clockwise direction. But the direction of rotation of all planets on their axis is not same. Most of the planets, they are also rotating on the on their axis in prograde direction. Exceptions: Venus and, इसका मतलब सारे प्लैनेट्स एंटी क्लॉकवाइज डायरेक्शन में रिवॉल्व कर रहे हैं, वो एंटी क्लॉकवाइज घूम भी रहे हैं ऑन देयर ऑन एक्सिस, एक्सेप्ट दिस वन. सो रोटेशन वाइज Venus and Uranus are moving in retrograde direction. Is this okay to all of you? So direction why that is the case? Did God plan that all planets should be revolving in same direction, anti-clockwise direction? Why that is the case? देयर एक्सिस इज टिल्टेड मोर. टिल्ट तो फिर अलग फिनोमेना हो जाता है, टिल्ट की वजह से अलग प्रॉपर्टीज जनरेट होती है. बट व्हाई दैट वुड हैव हैपेंड, we'll see that little later. For that you have to understand Einstein's space time theory, then you can understand why this is happening. So nature has some definite design. Coming to Kepler's law, Kepler's law of planetary motion. uh, so he gave 3 laws with respect to planetary motion. What are those 3 laws? अच्छा चलो पहले ये वाला चीज समझ लेते हैं, that we are saying that sun would lie at what, one of the focus, and let's say this is a planet. So the first law of Kepler, he is saying that planets are revolving around sun not in a perfect circular path, they are rather, yeah, moving in elliptical path. So the planets are moving in elliptical path, and the sun is assumed to be at one of the focus. Sun is at one of the focus of the ellipse. That is his basic idea. So planets are not revolving in a perfect circular path, rather they are revolving in some kind of elliptical path, where you have to assume that sun is not at center, or rather sun is at the focus. So can you see that the distance between the planet and the sun is not always same? Is the distance changing then? So sometimes it is the farthest away. What is this position called as? हाँ दोनों याद रख लिया इसलिए क्लैरिटी नहीं है. अब एपोजी दूर है, ओके, पास. So simple mnemonic, something which is away. So the farther one is the ephelion. The shorter distance would be called as the perihelion. Now comes the second law. Second law, he has given it in mathematical terms, but we can understand it in simple manner. The simple manner would be the speed of the planet around sun. Since it is not moving in a circular path, it is moving in an elliptical path. So do you think the speed of the planet here, velocity of the planet, so velocity at ephelion and velocity at perihelion be same? Where the speed will be more? So velocity at perihelion would be more, ephelion would be more. Why? It has to cover more distance, so it should be moving faster. Yes, sounds logical. No, what about this one? The higher gravitational force would reduce the speed. Okay, so the logic is right to the first part, but not to the second part. So now you are understanding that the force of gravity will be more here. The force of gravity by the sun here would be more because the distance is lesser. So if I stop, or let's say we have the power to stop the planet, what will happen to the planet if we stop it here? It will be absorbed by the sun. It means that it should actually be moving much faster because it is closer to sun. If something is very close to the sun, it has to escape the gravity of the sun, so it should be moving much faster here than compared to this situation. Even International Space Station, you would be aware, International Space Station is hardly 400 kilometers from surface of Earth, so it has to move very fast. It is circling the Earth 16 times a day. If you slow down, or if you slow it down, it will fall on surface of Earth. So because it is very close to the Earth can pull it towards itself, so it has to escape the gravity of the Earth, so it has to move very very fast. So objects have to move fast at this particular point, at the closer point. ये आपने ओलंपिक्स में भी कुछ गेम्स देखे होंगे. आइस स्केटर्स, हैव यू सीन आइस स्केटर्स? When they are spinning on their body or on their axis, if they open up their arm, they will get slower. If they close down their arms, they would start spinning faster. So you can imagine like that also. If you are closer, if you close down the distances, then you'll be spinning faster also. Okay. So just remember that velocity at perihelion would be much more than velocity at ephelion. So velocity is not constant, velocity will be different. At some place it will be faster, some place it will be slower. We know that when it is closest, it will be the fastest. Now the third law is not relevant for us, but Newton used this one only, and he gave that equation G m1 m2 by r square. इसी इक्वेशन को यूज करके उन्होंने वो अपना ग्रेविटी वाला इक्वेशन दिया था. What is t here? T means time period of revolution. Time period of revolution of the planet around sun. And r क्या हो सकता है? क्या r एक सर्कल है जिसका रेडियस हम लिख रहे हैं? यहाँ तो सर्कल है ही नहीं, तो फिर r क्या होगा? Average distance. So r would be average distance between the planet and sun. So r is average distance between planet and sun. But what is the practical implication of this for us, for exam perspective? For Earth, we know what is the time period of revolution of Earth. Earth का time period of revolution कितना है? 365 days and 1/4 of a day. This we know, or roughly we would say 365 days. For planets which are closer than Earth, let's say for Mercury and Venus, the time period of revolution would be less than 365 days. For planets which are beyond Earth, the time period of revolution would be much more. So it is just based on the simple idea that the farther away, or if the r is more, the time period of revolution will be more. That is a simple idea. So this will utilize while we understand Lagrange points also. Okay. So we can discuss about some planets, and based on that we can discuss about some missions also. कैन यू टेल मी अबाउट मर्क्यूरी? मर्क्यूरी के मिशंस पता है आपको? अच्छा, टेल मी अबाउट मर्क्यूरी, व्हाट डू यू नो अबाउट मर्क्यूरी? फर्स्ट प्लैनेट, ओके, क्लोजेस्ट टू द सन, नॉट एटमॉस्फेयर नहीं है या बहुत कम है बोलेंगे, ओके ठीक है. इज इट द हॉटेस्ट देन इफ इट इज क्लोजेस्ट टू सन? It is the smallest, okay, that we can also say. Will it be the densest also? No. Acha, is it the hottest? Why it is not the hottest? Because it does not have atmosphere. So you need atmosphere to hold on to the heat. Then which planet is the hottest planet? Venus is the hottest planet. So Venus has thick layer of atmospheric gases, and it has carbon dioxide and vapors of sulfuric acid. So it is the hottest planet. And Venus also has the highest, you can say, pressure also to a certain extent, and temperature also. Mercury is called as a cannonball because it is mostly made up of metal. So 85% of its component or its core is made up of metal. Venus is quite far away from Earth. How much time do you think it takes to actually reach to orbit of Mercury? Do we have any mission to Mercury of India? Mercury का कोई मिशन है हमारा? Venus के लिए है? Venus के लिए कौन सा मिशन है? शुक्रयान. But do we have any mission for Venus? Sorry, for Mercury. We don't have any. ISRO's mission is not there for Mercury. Probably it takes 7 years of time to reach to orbit of Mercury. तब तक सरकार बदल जाएगी तो क्रेडिट कौन लेगा? हाँ, पर अब नहीं बदलेगी तो चलो अब भेज सकते हैं मर्क्यूरी पे. So any mission which is relevant for exam with respect to Mercury. So one mission is relevant for you, which is Bepi Colombo mission. Bepi Colombo mission. This is a joint venture between ESA and JAXA. ESA stands for European Space Agency. JAXA is Japanese Space Agency. So they have sent a mission to Mercury. It was sent in 2018. When will it reach orbit of Mercury? It will reach in yeah. So by this year it is also, it might have reached or closer to this. So you should just cross check that has it reached to orbit of Mercury or not. So it is a relevant mission. It is an orbiter type of mission. It means that it will enter into orbit of Mercury. It will start revolving around Mercury and study the atmosphere. It will study the surface also, and then relay those information back to Earth also. So BP Colombo is a relevant mission. You will not see many missions to Mercury. Very few missions are actually there to Mercury. This is the relevant one. This is the ongoing one. Try to find out older missions to Mercury. So this is the relevant one. The older missions, like you would come across Mariner, Messenger. Give it a read, but not very relevant now. These are older missions of NASA which could be relevant from the sense that you should be aware that yes, there was something called as Mariner, something called as Messenger. So again, from NASA website, give it a read. Coming to the second planet, that is Venus. Yeah, tell me something about Venus. What do you know about Venus? Hottest planet, okay. It is the sister planet. We consider it as the twin sister planet of Earth. Okay, what else? Morning star. It is the brightest object after sun and moon. It is the third brightest object for us. So sun and moon are the most brightest object. Then comes your Venus. Then we have already mentioned about gases. We have also mentioned about pressure and temperature. The pressure is very high. The pressure is roughly around 90 atmosphere on its surface, and temperature, daytime temperatures can reach to about 480 degrees Celsius. at this pressure, even if you have a submarine, when submarine goes on deep underwater at 50 meter, sorry, 500 meters, it would start experiencing 50 atmospheric pressure. If it goes below that, it will implode because the water pressure would be very very high. So can you see, the pressure is very very high and the temperature is very very high, so nothing can survive. We have tried to send some probes down onto surface of Venus, but nothing has survived because everything gets melted there on surface of Venus. So Venus is our neighbor, we call it as our twin sister, but not a very favorable sister. s- Probably will not be able to live on Venus. Probably nahi, matlab, it is very certain that we will not be able to live on Venus. So we are looking at Mars. Why Mars? Because it has favorable conditions. Missions to Venus, are you aware? Hmm? So you should be knowing about Da Vinci, Envision, Envision, Veritas. All of these are future missions. And we also have our mission that is called as Shukriyan mission. And what you have to do here, you have to find out which one is sent by which agency. Da Vinci किसका है? Da Vinci नासा का है. ESA का. ये तो पुरानी चीजें हैं. I think you should have been aware. हाँ, so someone online is mentioning. Yeah, go ahead, go ahead. Okay, I'm not able to. Just a second. So you can get it from NASA's website. Do read about it. If you're not able to get, then we can discuss. So these are some important missions which you should be reading. One of them would be an orbiter type of mission. One of them would be where we'll be dropping a probe onto the surface of Venus. Shukriyan will be a simple type of mission, that is an orbiter type of mission. It was planned to be sent by 2022 only, but it has got delayed, and probably now the next time we'll be able to send would be in 2031. So in every 1.5 year we get an opportunity to go to this particular planet, but it has got delayed, so we have shifted the timeline from 2022 to 2020 2031 also. Coming to Mars. Acha, before we get to Mars, we can look at moon also of ours, and we can discuss about moon missions. So what is dark side of moon? What is south side of moon? What do you mean by far side of moon? What features of moon should you be aware of? How? What is dark side? Why is it called as dark side? Light doesn't reach there. We can't see. So we use that term in that perspective. Light reaches there, but we cannot see. So from Earth perspective, it is not visible. So we call it as the dark side. But light reaches to that side also. So dark side and far side, is it same or is it different? Dark side and far side are the same thing. So if you see these two terms, they mean the same thing. That is, dark side and far side are the same thing. South side is different. That is the polar side. Where has India landed? India has landed on the south side. Why or what advantages do you think would be there of landing on south side? तो मून पे जा रहे पहले मिनरल्स ढूंढने के लिए. Which type of water? Yeah, frozen water, or you can also say ancient water also. So frozen water in ice form. What is the advantage of studying frozen water? Yes, so we can get an understanding about how the water would have been formed and how the moon itself would have evolved. So that would be the idea. And if it is frozen, many of the things that have happened to moon would have been reserved there. So it would act like a fossil for information also. So we can get a lot of information if we are able to go to the south side of the moon. Also, we see a lot of craters on the south side, and that those craters are revealing the interior of the moon. So the south side would have lots of craters, and they would reveal the interior of the moon. Interior of the moon, studying the interior would reveal us how moon would have been formed. So still we don't have a conclusive theory with respect to what is the source of origin of the moon. Was it formed from Earth itself, or was it an asteroid which has started revolving around Earth itself? So we don't know the origin of the moon completely. So we can get an idea about the origin of the moon itself, and possibly of the solar system also. So those benefits are there of landing on the south side, but it is very difficult to actually land on the south side because it is very, very rugged. Since it is rugged, landing becomes difficult. So we failed to do what? You would have heard this term. We failed to do soft landing. So with respect to soft landing, what is the rank of India? So we have sent some missions: Chandrayaan 1, Chandrayaan 2, Chandrayaan 3. There is a plan for Chandrayaan 4. Can you tell me brief points about each of them? Chandrayaan 1 was which type of mission? Orbiter type of mission. Significant finding of Chandrayaan 1. आज मून के मिशन आपको कौन से पेज में है? 8th. ओके, हाँ 7 से हैं. ओके. So Chandrayaan 1 detected water. So this is the most significant finding of Chandrayaan 1. When was it sent? 2000. हाँ 8 9 बोल सकते हो, 9 में पहुंचा था. So 2008 you can say. The most significant finding was we found water in Chandrayaan 1 case. Chandrayaan 2, which year? 2019. You would be aware about that situation. K. Shivan was the chief of ISRO. Prime Minister was also present during the landing, and it crash landed. It failed to do soft landing. So which mission are we talking about? Chandrayaan 2, which was, what was the name of the rover? Rover was Pragyan. Vikram was the lander. So Vikram lander crash landed, and similarly the Pragyan also crash landed. You would be aware about this situation. So this year other countries had also tried. For example, Russia had tried. So this year Luna 25, they also failed to crash land. Oh, sorry, not failed to crash land. गलती से mistake हो गया. Luna 25, Russia, so they also crash landed on moon same year. Bereshit of Israel, they also crash landed on moon. So that spot that we wanted to be, what was the rank? We became 4th country to soft land. So we crash landed, they crash landed, Israel also crash landed. And you would be aware that K. Shivan started crying. Narendra Modi चुप करा दिया. Okay, yeah. What did he say? बहुत पैसा है, कोई बात नहीं है. अच्छा नहीं बोला, next attempt. So this would be more relevant for you. And both NASA and ISRO, they were not able to find where this Vikram lander and Pragyan has fallen on surface of moon. So they were not able to locate it out. One software guy from Bangalore was able to find it out. So he, using software power, and images were released by NASA and ISRO before the launch and after launch. He compared it, and he was able to tell the location. and he sent his findings to ISRO and NASA, but NASA and ISRO did not accept his finding. A few days later, they said that they were also able to find it out. But you would be aware that who actually gave the clue. So on his Facebook page, he writes his name and founder of Vikram lander, and that is his greatest achievement. Coming to Chandrayaan 3, this was the repeat mission, repeat of Chandrayaan 2. And we became the fourth country to soft land on moon. What was the first? We became the first country to land on south side of the moon. So that is an important achievement. Why we have landed on the south side? You know the reasons also. When you listen to terms like Neil Armstrong, Buzz Aldrin, they landed on surface of moon. Where did they land on moon? They landed on the equator of the moon. Now you are again saying Artemis mission. Artemis mission में जो प्लान है वो कहाँ पे लैंड करने का प्लान है मून पे? इक्वेटर पे या साउथ साइड पे या फार साइड पे? So Artemis mission, Artemis 3, they will be landing on the south side of the moon. क्योंकि आपको वहाँ पानी मिल जाएगा. What is water containing? Water is containing hydrogen and oxygen. Hydrogen can act as a fuel, oxygen can act as a fuel. So if you have reservoir of water there, then if you want to colonize Mars, you need to colonize moon first, and you need source of raw material, or you need the fuel, rocket fuel. The rocket fuel can be water, so it can be separated out. So that could be one of the intention also of landing on the south side of the moon. Coming to Chandrayaan 3, you have already seen which year? 23. So Chandrayaan was sent, 3 was sent in 2023. Chandrayaan 4 is planned one. Is Chandrayaan 4 mentioned in your notes? Okay. So what is the objective of Chandrayaan 4? Sample return. Yes. So one of the keyword that you should remember for Chandrayaan 4 is sample returner. So sample return करने के लिए क्या करेंगे? पहले तो collect करेंगे. So the rover, this Pragyan rover has drills. So it drills on the surface of the moon. It collects samples. It is storing those samples. We can then bring back those samples in Chandrayaan 4 mission also. It means where this one will be going, on the south side only. So जहाँ पे sample collect कर रहे हैं वहीं से उसको लेकर भी आएंगे. So this one will also go to the south side. Any other feature that has been mentioned for Chandrayaan 4? Sample returner. So can you see that it will be a round trip? So it will be landing, then launching from the moon, and then returning. So there is a table made there comparing Chandrayaan 3 and Chandrayaan 4. And it has mentioned that Chandrayaan 4 will have 2 launches. So we will be sending there will be 2 launches here, and the number of modules will be much more because it is more complicated mission than the Chandrayaan 3 mission. And docking experiment, are you aware about the term docking? Docking simply means connecting spacecrafts in space, or connecting two space objects in vacuum. That is what is called as docking. So you need docking experiments. There will be robotic drilling and re-entry again near South Pole Shiv Shakti point. तो शंकर जी पहुंच गए वहां पे, पहले नहीं थे. We are the ones who are giving that name. Okay, can you look at Changi 6? There is a table below which is mentioning about Changi 6 mission. Which mission of China became the first mission to land on the dark side of the moon? What is the basic principle because of which we cannot see the dark side, or we cannot see the side of moon, one side of moon? Tidal locking. What is this concept of tidal locking? Tidal locking का क्या मतलब होता है? Orbital period or rotation period same हो गया. So the basic idea is that the revolution time of moon around earth and rotation of the moon on its axis is same. If moon is taking around 28 days to revolve around earth, then it is also taking 28 days to spin on its axis. And because of that, our face we cannot see always. And why this happens? Because planets do that to the moon. So it was not that the moon was spinning so slowly. Can you see that moon is spinning on its axis, or it is making 360-degree turn in 28 days? We are making a turn in 1 day. So moon is taking 28 days to make a spin. Why is that the case? Because Earth's gravity has slowed down its spin, and it has reached to that particular point where the spin rate is same as the revolution rate. So we cannot see one side of the moon. It receives sunlight, but we cannot see that side of the moon. Most of the planets, they are doing that to their moon. This phenomena is called as the tidal locking phenomena. China was the first country to land on the dark side of the moon. Chang'e 4 mission was the first mission of China which landed on the dark side of the moon. How did it land on dark side of the moon? We will see that little later after we understand the Lagrange points, the halo orbit. Then we'll understand what is the feature of the Chang'e 6 or chain 6. It is the first ever sample return from which side? From far side of the moon. Slim was recently in news. So the news item below that is relevant for exam. क्यों relevant है? हाँ, और and Japan became the fifth country, fifth country to soft land on moon. So India became the fourth country, Japan became the fifth country. Is that mentioned? So just add that Japan became the fifth country to soft land on moon. Chandrayaan 3. So on the next page, Chandrayaan 3 is mentioned that you have already done. Luna 25, not very relevant. Blue Ghost, ये private space agency का है. Okay. Is Artemis mission mentioned? Artemis is not mentioned here. Where is it mentioned, Artemis? Page 17. Okay, so page number 18. Okay, Artemis they have mentioned very briefly. So yeah, so let us discuss then Artemis mission also. Artemis is relevant. Artemis mission. Now, Artemis mission, if you have to understand the context of it, you should also understand the Apollo mission. So, Apollo mission, which was sent, Apollo 11 is the most important one because this was the first human landing. So, why Apollo was sent? You should also know the context. So, 1962, Yuri Gagarin was the first person who was sent to space. He was a Russian astronaut. So he was sent to space. He went there. He went to 400-kilometer orbit. Then he was brought back safely to Earth. Overnight, he became a celebrity, but it led to space war between Russia and USA. USA president at that point of time was JFK, John F. Kennedy. He challenged the NASA scientists to not only send humans or Americans to just space, but to land them on moon. So his vision was that America should be landing Americans on surface of moon. NASA accepted the challenge, and in 1968 they sent the first Apollo mission. And in 11th trial they were able to land Neil Armstrong and Buzz Aldrin on the surface of the moon. After 1968, you would see that for next 3 years moon missions were done. It means more human landing was done till 1972. So Apollo 11 mission, this was conducted in 1969, and last Apollo mission where human landing was involved was 1972. After 1972, we have not seen any human landing on moon. None of the countries have tried. Neither Russia or China has tried landing on moon. So there is a big break or a big hiatus with respect to landing on moon. Now Artemis mission will be the one which will be breaking that long gap. So Artemis mission is considered to be more ambitious than even the Apollo mission. Why it is considered to be more ambitious? Because the idea is not only to land on moon, but in a way we want to colonize moon. The objective is we want to be interplanetary species. Elon Musk का ये view है, आपने पढ़ा होगा. एलॉन मस्क ये बोलता है कि ह्यूमंस एक ही प्लेनेट पे रहेंगे, तो एस्ट्रॉयड आएगा तो डायनासोर्स मर गए थे, तो ह्यूमंस कैसे बचेंगे. So he thinks that humans should be living not only on earth, but humans should also be living on, yeah, other planets like moon and Mars. So if you want to live on Mars and moon, then you should be able to actually have some stations there. So the objective here is to create a base station on surface of moon and to create a gateway in orbit of moon, just like we have international space station. So similarly we'll have a space station in orbit of moon and some kind of a base station on surface of moon. Why we are trying to do that? Because if you want to go to Mars, if you want to go to deeper in space, you can use it as an outpost. So do you realize this? Is it only about landing on moon? Artemis mission, it is not only about landing on moon, it is trying to create a whole human ecosystem out there, so on the surface of the moon and also on the orbit of the moon. So Artemis mission is considered to be more ambitious, so it will also involve a lot of complex missions. So Artemis mission has already been sent. Artemis 1 has already been sent. Artemis 2 will be crewed. It means astronauts will be present in Artemis 2 mission, but it will not involve human landing. What it is doing, it is testing the launch vehicle. It is also testing the human module where astronauts will be sent. So in Artemis 2, we'll be testing the SLS, Space Launch System. ये इनका launch vehicle है, one of the most powerful launch vehicle that has been ever designed. And then there is this Orion module. This is the module where the astronauts will be placed. This is the astronaut module. So in Artemis 2, the objective is we will be sending these astronauts to moon, to orbit of moon. They will circle moon and then they will come back safely to Earth. So this one will be a crewed mission, and this one has got delayed. So it was supposed to be launched this week only, but it has got delayed due to some failure in the cryogenic engine or some fuel leakages. Artemis 1 was non-crewed mission. It was just for testing this one, just for testing the SLS part. So here we would be testing the Orion module more specifically, so as to check whether we can send astronauts in this module or not. So the timeline for this one, this you know, अभी 2026 आ गया है, but 2025 के लिए planned था ये. Then there will be Artemis 3. Artemis 3 will be crewed, and this will involve landing on moon. But on which side? Not far side, south side. Yes, साउथ साइड में क्यों? क्योंकि यहाँ पे फ्यूल हमें मिल सकता है. वी विल स्टडी अबाउट क्रायोजेनिक इंजन. क्रायोजेनिक इंजन में जो फ्यूल होता है वो हाइड्रोजन होता है जनरली, एंड ऑक्सीजन होता है. सो ऑक्सीजन इज द ऑक्सीडाइजर, so we can use the frozen ice here to power the rockets also in future. That is why probably we are landing on the south side of the moon. It will be more difficult than compared to landing on the equator. Neil Armstrong and Buzz Aldrin, they landed on the equator side. Here we'll be landing on the south side, and after that there will be more missions. So there would be it is estimated that there would be around 8 to 9 missions also, and in between these main missions there would be sub missions also. इन सब मिशंस में क्या होगा? ऑब्जेक्टिव क्या है? सो ऑब्जेक्टिव यू शुड बी नोइंग that on surface of moon we are trying to create a base station, and in orbit of moon we are trying to create a gateway. Gateway would be like a space station जहाँ पे humans रह सकते हैं और रिफ्यूलिंग भी कर सकते हैं. So in between the main missions there would be sub missions where we would be sending such equipments to set up base station and gateway also. So do you think it is possible by NASA only? इतना सारा काम नासा अकेले कर लेगा? No. So it is led by NASA, but there are other space agencies involved. Which other space agencies do you think? रशिया पार्ट है इसका? क्या चाइना पार्ट है इसका? No. SpaceX private agency, but I'm asking first government agency. So it is led by NASA. Then others would be ESA, JAXA, CSA, Canadian Space Agencies, and private players would also be involved, such as SpaceX would also be involved, Blue Origin of Jeff Bezos, that would also be involved, and many other startups would also be involved for this particular Artemis mission. So this one is scheduled for 2027. So we are again entering into a historic era where we will see human landing on moon. पहला जब लैंडिंग हुआ था तो उसके बाद व्हाट्सएप यूनिवर्सिटी नहीं आया था. अभी व्हाट्सएप यूनिवर्सिटी में ये भी चलता है कि यूएसए ने लैंड ही नहीं कराया है मून पे. नो, conspiracy theories are also there. So do you think time has come to disprove those conspiracy theories? Probably NASA thinks so, that it wants to showcase that it is still relevant. And some critics are also pointing out that NASA is forced to send such kinds of mission because it might become irrelevant because of SpaceX. So SpaceX, the missions that they are having, the launch vehicles that they are having, it the NASA's missions, they have always been very, very costly. So it he can make the whole space ecosystem much cheaper and much more accessible. So NASA is probably trying to get back again on the relevance path. That could also be the reason that why they have planned for such a complex mission. पर इस मिशन में भी देखोगे आप स्पेस एक्स की हेल्प तो उनको फिर से लेनी पड़ रही है. एंड SLS, find out who has designed this SLS. Is it NASA, is it SpaceX, or is it some any other company? SpaceX है SLS के लिए या SpaceX है? बोइंग क्या कर रहा है इसमें? ओके, सो दिस इज मून मिशन. मून के और मिशंस आपको लिखे हुए हैं. Peregrine and these you can read for yourself. We are on page number 9. On 10 there is a table. Okay, page number 9, and then on the page number 10 you have a table for moon missions. Did you get that? Okay, coming to Mars now. What is the time? We have some time to discuss Mars, क्योंकि इसके बाद जो planets है उस पर बहुत missions हैं नहीं. So Mars, at least you should be aware. One concept you should also be aware. What can you tell about Mars in general? Okay, so you call it as red planet. Why do we call it as red planet? Because you see iron oxide. It means that there was presence of oxygen and possibly water also. So it could be a favorable planet for us to survive or for habitation also. That is why we are much more interested in going to Mars. We say that moon is the most explored object. We have sent maximum missions to moon, but with respect to planets, Mars is said to be the most explored planet. So maximum missions to planet have been sent to Mars only. So you should be knowing some of the missions. Some of the missions which are relevant for exam would be the Perseverance one. Perseverance पे last year question पूछा था. Last year there was a question. What was the question on Perseverance? What do you know about Perseverance? What do you know about Curiosity? We also have a mission. We also had a mission, in fact. Yes. Any Chinese mission to this planet? Chinese mission कौन सा है? Okay, Tianwen. Find out this name in your PDF. So Tianwen 1, 2, 3. और इसमें ये confuse करने वाले इनके missions हैं. So questions can be made from this particular portion. Just a second. No? Did you get the name Tianwen? Where? Which place? Topic number Page number 20 in the table, there is a name written as Tianwen 2. Page number 20, and there's a table there. In the table there is a name mentioned Tianwen 2, पर Tianwen 2 जो है वो एस्ट्रॉइड के लिए है, वो मार्स के लिए नहीं है. So there can be a potential question. So Tianwen 1 we are talking about. So we can discuss about this one. So let's first discuss about Perseverance. Perseverance is a rover. So it is one of the largest rover which has been ever sent to Mars. So it is a very big rover which has been sent to surface of Mars. It has a robotic drill which is collecting samples from surface of Mars. Now, is Mars away from Earth? So the amount of sunlight that it will be receiving would not be very high then compared to Earth. How do you think then this rover is running? सोलर से चलेगा, तो सोलर से फिर अर्थ पे भी चला लेते हैं सड़क पे गाड़ियाँ. Nuclear. So which type of source of power is there for running such rovers? इस पे सवाल भी आया था. What is RTG? Radiothermic generators. Now we'll discuss that in more detail in nuclear topic, because you don't understand now alpha decay and beta decay. But what we can say here, that we would be using some radioactive material. Which radioactive material is used for RTGs? Plutonium, which one? Okay, good. So we are using plutonium 238. What does plutonium 238 do so that we can power this one? It undergoes, for now just mention, it undergoes alpha decay, and because it undergoes alpha decay, it releases out heat, and that heat is converted into electricity by a mechanism which is called as Seebeck effect. So there is a thermal gradient. Based on that thermal gradient, it produces flow of electrons and it produces electricity. So plutonium 238, what is alpha decay? We'll see that in more detail in nuclear topic. But just remember that there is something called as plutonium 238 which would undergo alpha decay. It would release energy. That energy or heat would be used to produce electricity. It has a very good length, or it has a capacity to run the device for around 70-80 years also. So it has a very long life. So most of these missions where you need very long drawn source of power, you would be utilizing RTGs. Voyager 1 और 2, आपको क्या लगता है कैसे वहां तक पहुंच गए? RTGs से. So if you are sending such missions which are going into deep space, you need a sustainable source of power. One sustainable source of power is this RTG. Even Curiosity is powered by RTG only. Curiosity was also, it is still operational. So these are rovers of NASA which has been sent on surface of Mars. So you should be knowing about this particular aspect. Perseverance, it also had carried a helicopter called as Ingenuity. And Ingenuity made a history in 2023, I guess, because it became the first let's say helicopter which has flown on a planet other than that of Earth. So it has flown on Mars. That is why it became a history also. Now coming to India and China with respect to Mars. MOM1, the full name is Mars Orbiter Mission. So for MOM1, what are the few firsts that India achieved? When was this sent? 20? चलो 2013-14 में पहुंचा था. So 2014, it was sent in 2014. Mars Orbiter Mission. So it was an orbiter type of mission. It means we reached to the orbit of Mars. What are few firsts that India achieved? In India became the first country to reach orbit of Mars? No. In first, it was able to reach in first attempt, but India's rank actually was fifth. Do you think this is relevant? This kind of information is relevant? Yes, it is relevant because UPSC has been asking questions on this kind of format. So rankings become important. सॉफ्ट लैंडिंग में इंडिया का क्या रैंक है, क्रायोजेनिक इंजन के डेवलपमेंट में इंडिया का क्या रैंक है, सो विच कंट्री इज द फिफ्थ कंट्री टू सॉफ्ट लैंड on moon. These numbers, UPSC knows that you don't try to remember, so they will ask. So that is why you should be remembering this. India was the fourth country to reach orbit of Mars. Which do you think would be the first three countries? India was the first Asian country to reach orbit of Mars. Now, तो चाइना आपको नेगेट करना पड़ेगा. So by 2014, India was ahead with respect to reaching to orbit of Mars. The first three space agencies would be NASA, Roscosmos, and ESA. These three space agencies reached before us, but they were not able to reach in first attempt. We were the first country to reach orbit of Mars in first attempt. We were the first Asian country to reach orbit of Mars. It means, हाँ, रॉसकॉस्मोस. अच्छा, सो रशिया को आप एशिया में काउंट करोगे? ओके, चलो कर लेते हैं. सो coming to this one, MOM2, then we had a plan that we would be sending a orbiter, lander, and rover type of mission, and this was planned in next 5 years. That is, by 2019 we should have been sending the MOM2 or Mangalyaan 2 mission. Have we been able to send MOM2 or Mangalyaan 2? No, this has got delayed. So what has happened in between? China has landed on Mars. So they have sent a lander and a rover on Mars, and they were able to do that in 2021. So China became another country to land on Mars. So can you see, USA was the one which landed, Perseverance and Curiosity. Now China has been able to land on Mars. The name of the rover, in this case, is Raigu. Also, since it is confusing, with respect to Tianwen series, what you can do, Tianwen 1, this was for Mars. This we know. This was already sent in 2021. Tianwen 2, as you can see in the table, what is the plan for Tianwen 2? It is going to an asteroid. We'll see, or we'll study about asteroids a little later. So Tianwen 2, don't get confused that Tianwen 1 was for Mars. So Tianwen 2 would also be for Mars. So this can be a potential area of question making. Then Tianwen 3. Tianwen 3 would again be to Mars, but it would be a sample returner. And there would be T4 also, Tianwen 4. T4 would be for Jupiter. It is a future mission. तो चाइनीज को समझ पाना बहुत मुश्किल है, एक ही नाम में सारी चीज कर देंगे. So Tianwen 4, they would be going to Jupiter also. So this can be an area or confusing area. So can be a potential area of question making also. In same year, 2021, it was also relevant because UAE also sent a mission to Mars. UAE mission to Mars is called as Hope. Hope of UAE. So now you can see that UAE has also entered, a Middle East country has also entered into space arena, and they are also quite aggressive with respect to different types of space missions. So you should also be tracking what UAE is doing for Mars. Yeah. Tianwen 1, Z, Zenith, Zurong. Acha, sorry. Raigu to, sorry, yeah, absolutely correct. Raigu is name of an asteroid. So मेरा भी time हो गया. Yeah, so rightly pointed out. Zurong is the name of the rover. Raigu, Hayabusa जो mission था, Raigu asteroid पे गया था. So it is the name of a asteroid. So this is missions to Mars. Also, do try to find out any other mission. So Mars, we don't have any other which would be relevant for exam. Okay, so I'm leaving this up to you then. Find out missions for Jupiter. It has been mentioned there. Jupiter आपके notes में है in पेज नंबर जूस मिशन कौन से पेज पे है या पेज नंबर 32. So page number 32, you can see there are major missions to Jupiter and its moon that has been mentioned. So we have discussed about Mars. You can then study about Jupiter. Jupiter, can you see that there is a lot of interest in studying the moons of Jupiter and not Jupiter per se? Why Jupiter is of not much interest? It is mostly gaseous, and again the pressure and temperature would be very very high. A temperature is not very high, but the pressure is very very high. Since the pressure is very high, you would see hydrogen has got converted into liquid hydrogen. So gas has converted into liquid because the pressure is very very high, and we see oceans of hydrogen, liquid hydrogen there in Jupiter. So Jupiter again is not a favorable planet for us to survive. So life cannot be possible there. So we are interested in moons of Jupiter. So some of the largest moons of Jupiter. Which is the largest moon for the whole solar system? Ganymede is the largest moon, and it is the moon of Jupiter only. There are four large moons of Jupiter that you should be knowing. The names are mentioned there: Io, Europa, Ganymede, and Callisto. There is a table made out there: Io, Europa, Ganymede, and Callisto. And can you see that there is a mission which would be trying to cover most of these moons also? What is the name of the mission? JUICE mission. What is the full form of JUICE? Jupiter Icy Moons Explorer. So read about the JUICE mission from here. There's a Europa Clipper. Again, why the name Europa? Because named after the moon of Jupiter. And the Juno mission is an old mission. Juno mission was sent to Jupiter only. There was a question in mains on Juno, so I don't think there would be again a question made on Juno this time. But Juno was sent with certain objectives, so that you can read. They're not very relevant now. Past missions are also mentioned that you can read from there. Voyager 1 and 2. So here only try to add for other planets like Saturn and Saturn, Uranus and Neptune. ज़्यादा missions हैं ही नहीं उन पे, so you don't have to worry much. These are some of the important missions. What we'll do, we'll stop here for today. So tomorrow we'll be beginning with the asteroids and different types of missions to asteroid also. The test I think would be tomorrow then. Day after tomorrow. Acha, you are having polity test also. Acha, polity test was not conducted. 2 days after. Okay. Okay. Any doubt for today? No doubt for today. Okay. Can I share the notes on the group? Okay, that I can do. Okay, we'll do that. Online students, any doubt? No doubt. Either you are smart enough or you have not understood anything. Chalo, thank you. Okay, we'll see you tomorrow then. Same time.